Hello, everybody, and welcome to Echo Live, coming to you from the Michigan Science Center. We have a very special program planned for you today, so thank you everyone for joining. We actually have a very special presenter to talk about space, and specifically about the physics related to space travel in celebration of a pretty important event that happened this morning. So if you have been keeping an eye on NASA at all, you know that Chris Cassidy was launched to the International Space Station this morning, along with fellow NASA astronaut Jessica Meir and a Russian cosmonaut as well. What's special about this space mission for the Michigan Science Center is that with astronaut Chris Cassidy, he actually took with him a piece of MySci memorabilia. So he took with him a MySci mission patch that he actually took with him. He'll be taking a picture of himself with that patch in the cupola while he's on board the ISS for the next 6 months. Once he returns back down to Earth, we actually get to keep that patch. And that's something that you can come visit at the Michigan Science Center once we reopen to the public. So today we have another very special presenter. My friend Raul is here. So Raul, would you like to sign on? Hi, Raul. Make sure you unmute yourself there. How are you doing today?
Can you hear me now?
Yes, I can.
All right. Hi, Anna. How are you doing today?
I'm doing great, thank you. So Raul is here to talk to you all about the physics behind space travel. I know he's got a pretty fun program planned. Just a reminder to our audience watching through Zoom and through Facebook Live, if you have any questions for Raul, or you'd like to answer any of the questions that Raul asks of you throughout the program, make sure that you use the chat feature. You type your questions into the chat, we'll keep an eye on those, and we'll have some time to ask and answer questions throughout the program. So with that, I will let Raul take it away on our journey through space.
All right. Hi, everybody. Some of you may already know me. I'm Raul from the Michigan Science Center. You may have seen me on one of the Echo Lives. Thank you so much for joining me again today. So today I want to talk to you about one of my favorite topics in science, astronomy and physics. So right away, I want everybody in the comments to go ahead and type up their questions about space, astronomy, anything out there, okay? Towards the end, I'm going to try to answer some of the cooler ones. So if there's anything you ever wanted to know about space, astronomy, physics, now is your time to get your answers. So as Anna mentioned, Chris Cassidy actually went up to the International Space Station today at about 4:05 a.m. Eastern Daylight Time. That's 1:05 Kazakhstan time. And it took him about 6 hours to get to the International Space Station. So on the International Space Station, they have a MySci patch, Michigan Science Center patch. It's up there in space right now. We're going to get it when they come right back. Super cool stuff. So hopefully you guys come and check that out once we're open again. But I want to go ahead and talk about why space, studying space is so important. So in the comments, why might knowing a lot about the universe help us here on Earth? Go ahead and answer that question there for me. So the International Space Station is a laboratory in low Earth orbit, all right? Now, outside of our planet, there's outer space, and outer space is a vacuum. There's no air. And oh, it looks like we got few comments here. There we go. How many stars are there? That is a great question, actually. So that actually takes me into my next point. We're going to start talking about galaxies. So in space, we have these tiny little dots that we see up there, right? Well, with the naked eye from Earth, they look like stars. But if you have something like a telescope, a really, really powerful telescope, you sometimes see some really fuzzy objects up there. Now, those are galaxies. Galaxies consist of billions and billions of stars, and we live inside of a galaxy. In the chat, who knows what our galaxy is called? And to answer that specific question, at least for our galaxy, there are about 300 billion stars. Our sun is one of them. Do you know that the sun is a star? Now you know. Now, how many galaxies are out there? Well, billions and billions of billions. They're just really far away. So if you want to see them, we need very powerful telescopes. Now, there was a scientist called Edwin Hubble who liked to study galaxies. and he noticed that there were different types. So Anna, if you want to go ahead and pull up the galaxy slide for them. Thank you so much. All right, there we go. Now on the left there, you will see our Milky Way galaxy. That's a galaxy that we live in. And you see that there's this teeny tiny little yellow arrow there, and it's labeled Sun. That is where our solar system is. That's where you live. We live on the Orion arm of the Milky Way galaxy. But on the right, you'll see there are different types of galaxies. So there are elliptical galaxies. Those are roundish galaxies. Irregular galaxies, which are very diffuse, many kinds of them, varying shapes. Spiral galaxies, to me at least, they look like little spokes on there. You can see that they're all a little bit different. And barred spiral galaxies. They're very similar, but they're a little bit longer. Our Milky Way galaxy is a barred spiral galaxy. So I want to go ahead and go to the other slide that has that piece of bread. Some of you are probably wondering, okay, what does this have to do with the universe? What does this have to do with space, right? Well, Edwin Hubble actually noticed that our galaxies are moving. Some are moving faster than others. The farther you look out, the faster they're going away. And everything seems to be expanding away from each other, much like in the spread. So have you guys ever made raisin bread? When you put it in the oven, what starts to happen? Well, it starts to kind of expand. You have raisins on the inside going away from each other. And I think this would be a pretty cool thing to try at home. And we can do that with a balloon. Today, I brought our balloon of science. And you'll notice that on here, we have a lot of dots. And let me actually get a little bit closer here. We have a lot of dots. They look like stars. Let's pretend that they are galaxies. You want to use a pump. And start to add air in there. I want you to notice what happens to the space between those dots. So we notice that the dots start to get bigger and they start to move away from each other, right? Well, in space, galaxies are just moving away from each other. There we go. And the space between them gets bigger. Let me zoom in so you can see that just a little bit closer. So suddenly we have a lot more empty space between those galaxies. Now, Edwin Hubble discovered that using his famous telescope. There is a telescope named after Edwin Hubble called the Hubble Telescope. Why might it be important to study this? Well, let's think about today's technology. You'll notice that behind me, we have this rocket, right? It's called the Saturn V. The Saturn V took us to the moon about 51 years ago, back in 1969. The technology from the Apollo era is actually in your pocket right now. Our phones were developed because of that. Now, what are other ways that space travel and space exploration have shaped our lives here on Earth? If you know, go ahead and write some answers in the comments. All right, so thinking about this, do you think it would be a lot better if we studied space in space? Probably. Here's why. When we're stuck here on Earth, well, we're looking through the atmosphere, the gases that we're breathing in right now, right? And that can distort our view. Of course, we use different types of telescopes. We don't only use optical telescopes. We use radio telescopes. We use X-ray telescopes, all of that good stuff, right? Now, what if we were in space? Well, suddenly, there's no atmosphere that we have to look through. There's a lot less interference. We can build much bigger things in space and see much, much farther. Now, the International Space Station is a really good example of a laboratory that we can use to find how space affects the way that we live here on Earth. So right now, for example, they grow plants up there. What if the way that we grow plants here on Earth is different from space, right? There's no gravity in space, there's gravity here. So with those experiments, what we learn from them, we can use in the future. For example, if we go to Mars, we now know how plants will react, so we can make our own food, right? If we figure out very efficient ways of using the water that comes off of our body when we sweat, everything that we drink, we can recycle water once we get to Mars. Really super cool stuff. But before we even start thinking about that type of science, we need to start here at home, right? How do we get up into space? Well, rockets, of course, like the Saturn V. Chris Cassidy and the ISS astronauts actually used a Soyuz M16 rocket. But how do rockets work? Well, for this, we need to understand some very basic physical concepts. And some of the most important that we as humans now understand and use are Newton's laws. So let's get those out. Let's get Newton's laws out. Anna, can we get the Newton's laws? Thank you so much. So there are 3 laws. Law number 1, objects at rest and objects in motion remain in motion in a straight line unless acted upon by an unbalanced force. So what does that mean? It just means that things that are sitting down or things that are moving want to stay like that. The thing that changes them, well, it's an outside force. So if I have this little pump that we use for Galaxy, it's not going to move unless we add a force. So I'm using my kinetic energy to move it. All right. Number 2, force equals mass times acceleration. Now, what does that mean? Well, if you think about something really heavy, let's say we're using a little ball to try to move this, and we don't use too much force. Well, that's not going to move too much. It only moved a little bit, right? If I use more force, well, it moves even more. But what if I use something that has more stuff, like let's say my hand? Well, it moves much, much quicker, right? So anything that has more mass, it depends how much speed you put in there. That's what you're going to be seeing on the thing that it's affecting. And then finally, the 3rd law, for every action, there is an equal and opposite reaction. And this one's actually really important for space travel because we use that in rockets. So to talk about Newton's 3rd law, I want to go ahead and use this little plunger. You'll notice the perfect size for me to go ahead and put this ball. And we're going to be using a combustion reaction. So I brought something called isopropyl alcohol. This is a very volatile substance. That means that it turns into a vapor very quickly. And it's also highly flammable. This is a very good fuel. Now, I'm also going to be adding energy using my lighter, all right? One of the properties of gases, there's a gas in here, right? It's the atmosphere, the nitrogen and oxygen and carbon dioxide and all other gases. They react to energy. When you add energy to them, they like to expand. When you remove energy from them, they like to contract. So let's say I go ahead and add my isopropyl in there. We swoosh it around. Now the reason that I'm doing this is because I want it to evaporate very quickly. That should be good enough. So now we have a fuel source, we have a heat source, and we have some oxygen in there. Those are the 3 things that we need for combustion to happen. But now I'm going to go ahead and put in this little ping pong ball, and it fits in really, really tightly. All right. Finally, I'm going to go ahead and put my lighter in there. When I do that, those gases are going to expand really, really quickly, and that ball is going to shoot out really, really quickly as well. Now, the same force that is exerted is the same force that it's going to push back on this plunger. Same thing happens with rockets. So let's give it a try. Ready? 1, 2, 3. May have ran out of oxygen in there. Give me a second. Let's try it again. Look at that. Flew right out. And of course, for rockets, because they're very heavy, because they have a lot of fuel, well, they're going to need a lot more fuel and a lot more energy to leave the atmosphere. Now, another really cool thing that I like to do with this property is talk about substances that we can use in space. So let's say we were in space and we wanted to have a spaceship that we could be safe in. Would we be using very thin metals? No, probably not. Very thick metals. Today I brought this. You probably know what this is. It's just a soda can made out of aluminum. It's a really great conductor. Now that just means that energy can be transferred very easily in there. So I can add energy really quickly or take away energy very quickly. And I'm going to go ahead, put it on my stove here. This is a hot plate. Basically what I'm doing is I'm starting to superheat that can. Now all of the gases in here are eventually going to expand. When they expand, I'm going to go ahead and put them inside of the bowl next to it. This bowl has ice water, so it's very, very cold. So things that are very hot have a lot of energy. Those molecules are moving very, very quickly. Whereas something very cold like this bowl has very low energy. So we're going to slow down those molecules. So if those gases contract when I put that in there, what do you think is going to happen to that can? Go ahead and put that in the chat. We're going to have to wait just a little bit for this to heat up because it does take a little bit. And then, of course,
we have a great question while we're waiting for this gas to heat up. We have a great question on Facebook that says, could you quickly just re-explain how did that combustion reaction actually launch the ping pong ball? How did that work and how did it relate to Newton's laws?
Good question. So the exact same thing is happening here. We made that gas expanding here. Remember, this is a very volatile substance. This is a liquid right now, but when I start to shake it around, all of that gas starts to fill up the container, right? Now, when we go ahead and put the ping pong ball in there, we close the container off. All of that gas has completely filled up the container. When I add the fire, well, it's the same thing as adding all that energy into my can. Basically, what happens is we make that gas expand really, really quickly. Now, if my container is closed and I'm putting a super expanding gas in there, well, what do you think is going to happen? It's probably going to explode, right? That's exactly what happened. Rather than the container exploding, well, just the ping pong ball flew off, and that's exactly how that works. Really fun thing to do. I would not try this one at home because it can be pretty dangerous, but for my adults watching, I would try the can one at home. You don't necessarily need what I'm using. You can always just use a bowl of ice water and whatever you have at home. Use your discretion. Kids, do not try this at home. Ask for your parents' permission. But when you do, it's super duper cool. I think this might be getting hot enough.
All right, so we do have a couple great hypotheses about what might happen to the can. We have Liam saying that it might freeze the can because we've got some really cold water there. A couple people thinking that maybe it could disintegrate. Others saying that it could crush the can underneath the pressure. So we have some really, really great hypotheses coming in our chat. Some Ava in Zoom tells us that maybe we could create some steam as well.
Maybe we could create some steam. Actually, you're right. So let's go back over here so you can see really closely. You might not be able to see it on camera, but there's a teeny tiny little bit of steam coming out in there. Before the show started, I put a little bit of this water, just a couple of drops in there, so it had some other type of gas other than just the atmosphere in there. And someone said that it might be crushed. That is a really great hypothesis. If this thing is hot enough right now, it will be. If it's not hot enough, it's just going to stay the same. So you guys want me to take that gamble right now and try it? Of course, if it's not crushed, that just means that this isn't hot enough yet. It just needs to sit a little more. Exactly. So it does just need to sit a little bit more. Let me take a couple more questions.
Sure. So we have a really fun question on Facebook. Katina asked, are you an astronaut?
I am not an astronaut. I studied physics and astronomy in college, so I'm a different type of scientist. Astronauts are super duper smart. They took so much school. They sometimes study for life, right? So I only studied to be able to teach physics and astronomy. They studied for flight. They take really hard tests every day. It's a completely different world, and this is why we love and respect our astronauts so much. They are really brilliant people. Let me get another question. I love these questions.
Sure. Jennifer asks us, how are stars formed?
Ooh, how are stars formed? Good question. So stars, when you think about it, they're made out of gases, right? Why are they made out of gas? Well, because they are supermassive and all of that has a lot of gravity, right? When you have a lot of stuff or matter in a very condensed place, well, there's energy being exerted. So little teeny tiny particles come together, or sometimes, yeah, they come together to form new things, right? So this is what we call nuclear fusion. So protons, electrons, neutrons all interact in what we call molecules, which are the building blocks of everything that you see. And when stars explode, well, we have gases, we have new elements that are heavier. They come back together and form new stars, baby stars. They form new planets. They form everything that you see. And there are different types of ways that they're formed. So if it's a really, really massive star, it sometimes explodes. And this is what we call a supernova. Now, from a supernova, you can get what we call a nebula, which is, it just means cloud. Basically, you have dust, new stars forming in there. Sometimes you can get a neutron star, which is a super duper condensed star, super dense, and they're really, really cool. But sometimes you could get a black hole. Now, those are points in space where space and time are ripped. Very mysterious objects, really, really cool things. We actually just took a picture of a black hole in M87. So go ahead and Google that. Super duper cool. We didn't know if we could do it, but we took a picture of the shadow of that black hole. Hope that answered your question. Any other questions?
Yeah, so we have two questions kind of about the same topic on Facebook. One person asked, what is a black hole? And someone else asked, do you know what the closest black hole to our solar system is?
Okay, so a black hole is basically a dead star. It's a really, really big star that went supernova and exploded, and everything came together to an infinitely dense point. Now, something really, really cool to a black hole is about black holes is that the gravity is so strong that nothing can escape them, not even light. So that's why we call them black holes. We can't see anything, but we can see the things around them, right? Now, there is the edge of a black hole. So let's say this is the black hole. That edge is what we call the event horizon. Everything outside the event horizon, I can see. Once it crosses it and goes in there, you can't see it anymore. Really crazy stuff. And there may be black holes really close to us that we just haven't found. They're very hard to detect, especially visually, right? That's why we use radio telescopes and other types of wavelength of light to try to find them. All right. One more question.
One more question.
Yeah.
Is there a galaxy close to us that is colliding with us?
Ooh, yes. So in about 4.5 billion years, an object known as M31, we call that the Andromeda Galaxy, will collide with the Milky Way galaxy. And the brand new galaxy is going to be called Milkdromeda. Science fact. Make sure you mark your calendars, right? Great questions. All right, so let's do our grand finale now. I see that steam forming. Let's go ahead and test our hypothesis and see who was right. Ready? 1, 2, 3.
Whoa!
Look at that. So it did implode on itself because those gases, they condensed in there. Really, really cool stuff. Again, kids, don't try this at home without a parent. If you do, it's a really fun experiment. Thank you so much for joining me today. If you have any more questions for me or Anna, please let us know. And I hope you stay with us for this duration of the time. Thank you so much. Thank you,
Thank you
Anna.
so much. Cool. So stick around. We'll see if we get any last minute questions here. Thank you guys, everyone, for joining us here for another episode of Echo Live. If you're looking for any sort of space activities or science activities that you can try at home, maybe we can add that can crush demonstration that you can try at home with parent supervision, of course. We will post those on the Michigan Science Center website, of course. Again, this is a great time for us to, as always, thank our sponsors like the DTE Energy Foundation and to the sponsors of the Science Center that are allowing us to bring these Echo Live programs to you at home every single weekday at 2:30 p.m. Eastern. I know we have people joining from all across the country. This is amazing for us. We're so excited to have you here. We'll be back again tomorrow with some more science experiments that you can and should try at home. Activity guides will be coming with those ones as well. So we hope we'll see you back here tomorrow. Let's see if we have any last minute questions in the chat. Raul, if you're up for maybe one or two more.
Yeah, go for it.
Sure. So someone wants to know what happened. So you did kind of explain this. When the two galaxies collide, what's going to happen to us?
Good question. So we're probably not going to be here. In about 5 billion years, our sun is going to turn into a red giant. And that red giant is going to expand out to the asteroid belt. But let's pretend that we were here, all right? Many things could happen. Would that disrupt our solar system? There is a possibility, maybe not. The real question, the real answer is we really don't know yet. And it's okay to not know things. That's why we use science, right? We want to keep investigating.
I agree, right? If Raul knew everything about space science, why else would we keep exploring, right? But thanks,
Exactly.
Raul. Great answer. So a lot of people are telling us, thank you so much for such an awesome program. Raul, this was really, really fun. And I know we'll be back here again next week with some different science topics. So thank you, everyone on Facebook and on Zoom for joining us here. We hope we'll see you back here tomorrow. Have a great rest of your day.